All right, so starting the next chapter here is going to be some, I'll say, basic rules for working with variables, but they're probably all going to be new to you. So the first one has v to the third times v to the sixth. If we think about what an exponent means, if something's v to the third power, it means you're taking a v times another v times a third v, right? V times v times v. If I have v to the sixth power, means I'm going to have v times v times v times v times v times v. 6 of them. So if I look at that list and I'm doing v times 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 v, I can really rewrite all of that as v to the 1, 2, 3, 4, 5, 6, 7, 8, 9th power. So what they're going to tell you as a basic rule in algebra, if I have x to the m power times x to the n power, they're going to say that you have x to the m plus n. When I'm multiplying, if my bases are the same, I'm adding the exponents together. 3 plus 6 is 9. Because obviously we wouldn't want to have to write all those out all the way. We just can take a shortcut. So if I'm going to do u to the fourth times u to the fourth times a u, all I'm going to do is add my exponents up.
So would you add that 1?
Exactly. I have 4 plus 1, which is 9.
Okay.
So u to the fourth times u to the fourth times u is u to the 9th. So number 3, we have y to the 5th times y to the 4th times y to the 3rd. I'm going to end up with y to the 13th, exactly. So when I'm multiplying, if my bases are the same, I add those exponents together. That's your first rule. So now we're going to put it in terms of what they call multivariate expressions. I've got more than one variable. Basically, when I'm multiplying, I could have a dot between every one of those things, but we usually don't put a dot between our number and our variable. What we're going to do is just basically rearrange this and put all our numbers together, all our v's together, all our w's together. So we're going to do 3 times 4 times 2, doing the coefficients of each of those terms. I've got a v and I've got a v to the 9th. I've got a w to the 9th and a w to the 6th. So I'm going to multiply with the numbers. I have to just multiply them like I normally multiply. 3 times 4 times 2 would give me 12. 12 times 2, 3
24.
times 4 times 2 is 24. And then I use my rule that I just learned. My bases are the same, I add my exponents. So if I take v times v to the 9th, I get v to the 10th. W to the 9th times w to the 6th would be w to the 15th. And so my answer is 24 v to the 10th, w to the 15th. So the numbers I do the normal way. The variables, I have to follow my rule for my exponents. If I'm multiplying, I add my exponents. So you probably really don't need to rewrite all of that like I did unless it makes it easier for you to figure out. But you're going to look and first do your numbers. I have a 2 times a 2 times a 4. So we get 16. Then doing my variables, I have a y times a y to the 4th. So y to the 5th. And then I have a w to the 4th times a w to the 5th. W to the 9th. So 16 y to the 5th, w to the 9th would be my answer. And the order of your variables isn't really important. If you put the w first and then your y, that would be all right too. So, number 6, if you're going to multiply 3u to the 9th times 3x to the 8th u to the 4th times 4x, what would I do?
3 times 3 times 4. Okay, 9 times 4 is 36.
Mm-hmm.
9 and u4. U13.
Okay.
And then x8 and x9.
So we get 36, u to the 13th, x to the 9th, and that's going to be my answer.
It looks so complicated yet so easy.
Number 7 is our rule when we're raising to a power. So first of all, to explain it the long way. If I have x to the 6th raised to the 3rd power, the 3rd power means I'm going to take an x to the 6th times an x to the 6th times an x to the 6th, right? If I follow my rule I just learned on the previous ones, it then says I'm going to add my exponents. 6 plus 6 plus 6 would give me 18. So the shortcut there, do you recognize what the shortcut is? What happens when I do 6 times 3?
Okay.
So if I'm raising to a power, x to the m raised to the nth power, I am going to multiply my exponents. When I raise to a power, I multiply those exponents together. So if I use that rule on number 8, I have y to the 4th and I'm raising it to the 4th power. I'm going to end up with
4 times 4 is 16.
y to the 16th, exactly. And number 9, although it's way down there, I'm just going to leave it there since it's the same rule. If I have w to the 4th raised to the 5th power, I would get
4 times 5 is 20.
w to the 20th power. So in my head, I always think it's one step lower. When I multiply, I end up adding. When I raise to a power, I end up multiplying those exponents together. Oops, keep forgetting. I got this new one on here. I got to do it different. So, again, thinking of this one the long way first. If I'm going to take 2x to the 3rd, what that means is I'm taking a 2x times a 2x times a 2x. Which means I'm going to do the 2 times the 2 times the 2, which is 8, and then x times x times x, which is x to the 3rd. So when I throw numbers in with variables, I'm doing the numbers the normal way. I'm doing the number as 2 to the 3rd power, 2 times 2 times 2. With my exponents, technically, again, I'm multiplying. 1 times 3 is 3. They'll get bigger exponents as we go on, but these first ones are just going to be to the 1st power anyway. But that's what's happening. I'm doing 2 to the 3rd by doing 2 times 2 times 2. I'm doing this by multiplying my exponents, x to the 3rd. So if I have 6y and I'm going to square it, I'm going to end up with
36y.
36y to the second power, because 1 times 2 is 2, right? Otherwise, I could write it down twice. 6y times 6y, 36y to the 2nd power. And again, I got this one way down here, but since it's the same rule, if I take 2w and I raise it to the 4th power, I would have 16 to the 4th. 16w to the 4th. If you took 2w times 2w times 2w times 2w, you get 16w to the 4th. So now they just make it a little bit longer. Now they throw all those different variables and whatever in there. So what I'm thinking about when I raise it to the 5th power is either I could write it down 5 times, which I probably don't want to do, or I can just separate it and say, okay, I'm going to take the negative 2 to the 5th power, and then I'm going to do the v cubed to the 5th power, and then I'm going to do the w to the 5th power. Each of those things separately. So when I do negative 2 to the 5th power, I have to do that the normal way. Negative 2 times negative 2 times negative 2 times negative 2 times negative 2, or use my calculator and be sure I use the parentheses around it.
Oh, okay.
So negative 2 to the 5th power gives me
I forgot how to do powers.
the
This thingy,
caret key. Yep, that thingy there.
and then
5. Yep.
equals negative 32.
Negative 32. So if you took negative 2 times negative 2 times negative 2 times negative 2 times negative 2, you get negative 32. Now here's my rule that we just had on those previous ones. When I raise to a power, what do I do with my exponents? Multiply them. So I'm going to get v to the 15th, and then w to the 5th, because it's going to be 1 times 5, which is going to be 5. Like we did on those previous ones that all just had that plain variable. That exponent's on the outside, it's going to stay there. So, number 14, I want to get rid of my parentheses. I'm raising it to the 4th power, so I'm going to do the negative 3 to the 4th, the u to the 4th raised to the 4th, and then the w cubed raised to the 4th. So if I take negative 3 to the 4th power, parentheses, exactly. You better use the parentheses if you're using your calculator.
81.
Going to be positive 81 because I have an even exponent, right? Then I'm going to get u to the 16th and w to the 12th. Because when I raise my exponent to a power, I multiply my exponents. So number 15, if I have 7vw to the 4th and I'm going to square that, what am I going to get for my answer? Forty-nine. V to the 2nd and w to the 8th, exactly. And then, just to make it a little bit longer, we throw in some fraction ones. Same rules, though. So when I'm thinking of this, I'm dividing each of these, and I'm doing the y squared, raising it to the 5th power, the negative 2 on the bottom of the fraction, raising it to the 5th power, and the x to the 4th, raising it to the 5th power. So if I take y squared and I raise it to the 5th power, I'm going to get y to the 10. If I do my negative 2 to the 5th power,
Negative 32.
negative 32. And if I do x to my 4th raised to the 5th power,
X 20.
x to the 20th. Now, if you guys put this one in like that, it's going to say it's correct, however. We know by now, hopefully, that Alex doesn't like negatives in the bottom of the fraction. So if you put it in that way, it'll say it's correct, however. The better form would be putting the negative in front, because a positive divided by a negative makes the whole fraction. Whoops, that's supposed to be a y on talking and trying to write at the same time. So, y to the 10th and x to the 20th. So it's putting the negative in front of the fraction instead of on the bottom of the fraction. In introductory algebra, it still counts it correct. By the time you get to college algebra, then they start hacking on you. So you want to get used to, oh, if there's a negative on the bottom, I'm just going to put it in front of my fraction. So number 17, same kind of thing. I'm going to raise that all to the 2nd power. So I'm taking the x to the third and I'm going to square it. I'm going to take the negative a to square it, and I'm going to take the z squared and square it. So I would end up with
X to the sixth
x to the sixth
over 64 and Z to the fourth.
over 64, z to the fourth. And on that one, we had a negative times a negative, so we got a positive 64. We don't have to worry about the sign on that one. And so number 18, if we take 3a to the fourth over b and we raise that to the fourth power. $81. A to the 16th over b to the fourth. And that's going to be my answer then. So two basic rules. If I'm multiplying and my bases are the same, I add my exponents. If I'm raising it to a power, I multiply those exponents. Those are the two rules they want to get across on that page of paper. All right, that should be the next 6 things on your pie chart. Only I probably have to open the other chapters up. I suppose it's only going to let you in